up guys, it's Ziggy back and I have a new video for you. Exactly. I'd love to say the current date and the time, because in the future when I watch the videos myself, then I can always remember, it was that and that day and that time when I made that thing. Because of that, I just show you, it's November 15th, Saturday evening. It's near 10 p.m. And this video is to show you, I want to show you a little bit of an introduction to ROS2, to Robot Operating System. I don't know how much you've already heard from it. I will probably say not so much, because ROS2 is more like, it's not an user-friendly thing, I will say. It's more used, until today, it's more used for research in the universities or etc. etc. But with the technology always progressing, ROS2 is also, ROS2 is, by the way, the next step to ROS1. ROS1 was a few years ago, the first ROS version, as in the name, and now it's ROS2, exactly. And with ROS2, many things are already really good and really user-friendly. So today I will show you a little simulation with ROS2. In that simulation I have a robot with 2 wheels and a caster wheel, like a Turtlebot robot. This is it's a university robot, Turtlebot, but I've made that robot myself, so I modeled it myself, and I will import it in Gazebo. This is the simulation. You can imagine that when you don't have a real robot by hand, or you don't have the motors, you can use Gazebo. It's a complete simulation with gravity, with etc. physics, etc. 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 So I will use that. It's also a common thing in robotics, because you can't test it always in real life. You don't have the environment or something else, so you need to have simulation, and with that is Gazebo, exactly. And in that Gazebo I will spawn the robot. So Gazebo, that simulation, is then on, it's just a thing, because I don't have a real robot. You can, I would also be able to have a real robot and use it, ROS, the same thing, but now it's Gazebo. Anyway, so I don't talk much longer. I will just show you here that to you. Currently, as you can see it here, I need to say, because ROS2 is a really big theme, I will don't tell you now every little detail, because that would be, it's so much stuff and theory that I could speak a week straight on without a pause and still have things to tell you. So I will just focus. This video is just a representation. I will just show you how I started. You see how it works. So you have a little sightseeing, a little tutorial of ROS2, Gazebo, and the robot. Exactly. We will also use a SLAM, simultaneously localization and mapping. This is the algorithm. So the robot will, also in Gazebo with a virtual sensor, a virtual LiDAR sensor, will map the environment. So in here, it would map where the doors are, where the walls are, where things will lay exactly. It will map it. You will just see it in a second. It will map it and then create a map, and that map we will use then again to spawn the robot, and then the robot can move in that map itself. It's a little bit complicated, but I will just start it. The first thing in ROS2, now I have here such a launch file. You can imagine that as a start file. It's just a starting file that all services are started, yeah, when I execute this. And you also see here ROS2 is more or less completely in terminal. So terminal or editor. So you don't have here a graphical interface, more or less, yeah. Okay, that file here, which I will start now, will start up Gazebo and ROS. What ROS is, yeah, you don't need to know it exactly now, but it's also just a visualization. It's not a simulation. That's Gazebo. It's a visualization, exactly. So I will start that file now. Here you can see it executes, and voila, it's already popped up. Yeah. So what we will see here, I will start with that one here. That's Gazebo. That's a real world simulation. So voila. Just here. Here you can see that's our robot. So the robot I made. Exactly. This robot here also has a LiDAR sensor on it. I can just visualize that with that one. LiDAR here. Visualize LiDAR. Exactly, and then I can put it on here. Zack. And now you can see the LiDAR arrays. The LiDAR arrays, sorry. Yeah, so that is a simulation now. The simulation is already running. So the things here, the LiDAR arrays are, yeah, you can see here, hit the objects, hit the environment, and then the LiDAR sensor know where things are in the room, exactly. And I will go to Gazebo now, because like that here, exactly. That and that we don't need now. That's ROS here. That's just a visualization. You can imagine that so. The LiDAR, this one here, the Gazebo, is our real world. So you can imagine that robot could stay here. Yeah. And you can imagine it's logical in a simulation, you see the environment here in it. But this is just a real world exchange. So you can imagine this here is the real world. So this robot would stand here and you don't see the LiDAR arrays. Yeah. So you need a visualization for that. And then comes here ROS in the game. Exactly. That here you can see we also have that robot here, our robot, also imported here. Exactly. And you also noticed here those red points, and you can already imagine that are the LiDAR points. Exactly. So the LiDAR points from the real world or the simulation here, you can see it here, this one here and this one here, these are edges. This has the LiDAR sensor seen, and is it now visualizing it here in ROS. Yeah, so this robot here knows now here is an edge or here is an object, I can't go in there. Yeah, exactly. So what's the next step? The next step, I will just show you a little thing of it. Now SLAM comes to work. SLAM is already running here. That's that algorithm, simultaneously localization and mapping. I need to map the environment now. Yeah, the simulation knows how the environment looks like, but here in the visualization, it doesn't know. So I need to map it, exactly. And with that one, that's just, you can imagine that you just need to drive through, through the environment with your robot, yeah. And with that, I can also, because this is a simulation here, I can also simulate the driving of it. So I will just start here the steering. I will put that a little bit up. Here you can see I can now controlling it with the keyboard here. Yeah. So I will put that a little bit down so you can see it. I will also put that here a little bit besides. So you can see here the Gazebo simulation. I will hopefully I will make that follow so we can follow the real robot here. That one I will pop a little bit up here so you can see it very good. And now I will take the keys here. And now I will drive a little bit with the robot and you will see how the environment maps. So you already saw here, you can watch left and right. Both robots are moving. That's because the simulation is now, the simulation or the real world robot would move now. And that information, the information of the wheels, of the motors, will go through ROS2, for that is ROS2, Robot Operating System, will map then here in the visualization. And so the system always know where the robot currently is. And you can also see it here, as I go through the environment, here the map becomes more lighter. So that basically means that the SLAM, that's that algorithm, is mapping the environment. You can see it here. Before it was more or less everything gray or black, and now you can see it here. This one here, probably, for example, is that one here, that obstacle. Yeah. So it mapped just in a 2D card, in a 2D map. It just got here the information that here is an obstacle, you can't go here because of the LiDAR information. Yeah. And that is just basically it, the first step. So you will drive here with the robot, map the environment with SLAM, with that algorithm, and then when you are completely finished, so I will stop it here now. When you are completely finished, you will, this is a big map, so this would take a while. This is a complete warehouse here, simulating. It will take a while. I've already did that for you, so we will skip now to the next step. So you can imagine I've now mapped the whole thing. And what is the next step? The next step is I can now import that map and then also again place the robot, my robot here, in the simulation or in the real world. And then because of I need to say, I will load the map, which we mapped. Then I will say where the robot currently is in the map. So if it would be in real world, I will say, hey, the robot stands here on the map, exactly. And then the robot and the ROS2, Robot Operating System, knows where the robot is, also in its system, so in the computer itself. And it can now compute and navigate alone through the map. And that I will just show you. For that, I will need to adapt a little things shortly. I will firstly cancel these things here. Exactly. So the simulation and the ROS is closed. Then this one I will also, this is the controller with which I controlled it. I will also can make that go away. So now I will need to adapt here a little bit of code. This is XML code. I don't know if you've heard of it. I don't go into any details now because it would be too much, but you can just imagine that, you can just imagine this code is starting all the processes from the ROS2 services we are need now. Yeah, exactly. So I've made that here, that change. Save it and I can rerun it. Voila. And now I can rerun it. Voila. Now it's again starting Gazebo and starting ROS. And what you can see here, I've told you, it will load in the map. Voila. You can see it here. That is the completely map. Localized and mapped. Yeah. So I go here in the warehouse, in the simulation here. That is the real world, or again the simulation. But you can imagine that as the real world. So you can see it here now. These things here, and this things here, it's now otherwise. So a little bit up here. You already see it here. This warehouse things here are mapped here exactly, and this one here and this one here, these are all mapped now. So the the system knows how the surrounding and the obstacles around the robot look like. Yeah. So now you can see here the robot, the simulation robot or the real robot is already here in it. So I could steer it now, but we don't steer it because now it's steering itself. The only thing I need to do now, as I told you before, I need to tell the system where the robot currently is. So it has here the map, but the system don't know where the robot here is. So but basically it's on origin 0, 0, because it knows where 0, 0 is. It's where the robot here is spawned. But anyway, I need to tell him now. I can tell it here by from hand. With that, I have here that function, and then I can just say I need to watch here. It looks that way, so it's reversed here. So I can click here, and the arrow here is showing which direction the robot look forward. So that one, voila. I've just told the system now where the robot is, and you can see it here. Now it knows where it is and how it looks like, in which direction, and it's again in the simulated world or in the localized world. And I've just need to tell you it's a little bit wrong here. You can see it here now. The LiDAR sensor data and the mapping is not quite correct. It's not, so the position is not 100% correct. But anyway, we will do it, we will work with it anyway. You need to be more or less precise with that position. So I'm just a little bit far back here, I think, yeah. The robot here is much, I can here put it a little bit more before. Yeah, already a little bit better, huh? Yeah, it's more here. Yeah, that's better. A little bit back. So, I will leave it like that. So, and now with the navigation ROS function, the robot can now compute and move alone through the environment, and also has obstacle avoidance, so it could dynamically or it should be able to dynamically avoid new appeared obstacles. So this mapped environment don't need to be static. I will show you that now. Dynamically placed objects or obstacles which are in the way of the robot, he will see, because the LiDAR sensor is still running. I can visualize that here for you, that you have a better understanding. LiDAR sensor, again, that's the sensor which maps the environment. Yeah. So this is all. This is still running, and now I can say, without commanding the real world robot, I can say now in the system, hey, robot, please move yourself to that location here and find the path by yourself. And you can see it here. It will start automatically. I don't do anything. And you can see it here also in the simulation. The robot is moving by itself. Yeah. And as I told you before, if the real world, I will just set it here until it's reached its position. I will show you it I will just show you it in a second. Because the LiDAR sensor is just already is still running. The robot, when an obstacle is now in its way, it will just see it with the LiDAR sensor and avoid it. Find a different path around that obstacle. So I will just do it again. I set the goal here. Hey robot, please move yourself to that position. Find a way. Yeah. You can see it here. The robot is still moving. And now, because I need to do that in the real world, because in the real world a human probably can appear in front of the robot. So I will place that here. That is now just a block, but you will see it here. The block, he sees the block and goes around the block without touching it. Everything dynamically. And you can see it here, it already maps that block. As I told you before, the map is a little bit wrong. But anyway, it works for now. Yeah, as you can see it here, the block was visualized, and the system now knows, hey, there is a new block, a dynamically appeared block. So you just saw it here. Also, if a human probably appeared in front of that robot, that would be no problem. He just goes around the human. Yeah, and that is, if you ask me, that is a really nice thing, and that is really fascinating me for ROS 2. Yeah, exactly. Now you just saw a little introduction to a simulation of a robotic system. I know it's very abstract here. You probably saw that programs the first time and don't know where I clicked here, or don't know what are these terminals, what is even a terminal. But anyway, the result is mattering. So you just saw the result here, what ROS 2 can do in a simulation or in a real world. So I can adapt, if I have now a robot with 2 wheels and a LiDAR sensor, I can take here a few motors, place it on the ground, and then can map the real world. Yeah, just like that. Yeah. So with that, I hope you've probably have a new interest now in robotics or ROS 2. This was just a little introduction to ROS 2, robotics operating system. I will leave it like that for now as a beginning video. I think it's very good, and in the future I am planning to make ROS tutorials. So there is so much stuff behind ROS. There are topics, action servers, service servers, there are URDFs, how you can define your robot, again how to import it in Gazebo, how to make it with real hardware interface, just many things to cover. And I will think in the future I will make ROS tutorials, ROS 2, to also make ROS more available to the world. There are good tutorials already on Udemy Pro, for example, where I learned those things. These are good tutorials, but I will think I will teach ROS 2 in a more reality, in a more real, how would I say, in a real environment, not so much theory, not so much simulations, more of a real robot. But anyway, I will leave it to the future. I think this is enough for now, and I hope that video was good and interesting. I hope so. And yeah, if you like that video, give it a good comment, or yeah, subscribe my channel. It would be a pleasure to me. Or if you have any questions, yeah, write it in the comments, and I will say then I see you there. Bye.